In this research paper titled, TimeSoccer, an end-to-end multimodal large language model for soccer commentary generation, the authors from East China Normal University introduce a new AI system designed to automatically generate detailed and accurate commentary for soccer matches. Soccer is one of the most popular sports globally, with matches that can last up to 90 minutes, featuring long periods of play interspersed with key highlight moments. The challenge here is to create commentary that not only describes what's happening on the field but also precisely aligns with the exact times of events in the video. Traditional methods for generating soccer commentary often follow a two-step process. First, they identify and timestamp important events in the video, and then they generate descriptions for those events. This approach has limitations because it doesn't handle the video as a whole, leading to inaccuracies in timing and a lack of context from the broader match. For instance, it might miss how one event builds on another over the course of a 45-minute half. Existing multimodal large language models, or MLLMs, which combine vision and language processing, typically rely on predefined timestamps, meaning they can't process an entire soccer video from start to finish in one go. To address these issues, the authors propose TimeSoccer, the first end-to-end MLLM specifically for a task called Single Anchor Dense Video Captioning, or SDVC, in full-match soccer videos. What this means is that TimeSoccer can take a long video of an entire soccer match and, in a single pass, predict the exact timestamps of events while simultaneously generating rich, context-aware captions. This end-to-end approach allows the model to understand the global context of the game, capturing not just isolated moments but how they fit into the overall flow of the match. A key innovation in TimeSoccer is the introduction of a module called MoFA-Select. This is a training-free, motion-aware frame compression technique that helps the model handle very long videos efficiently. Soccer videos contain thousands of frames, and processing all of them at once can be computationally intensive. MoFA-Select works by adaptively selecting the most representative frames using a Coarse-to-Fine strategy. In simple terms, it starts with a broad overview to identify areas of interest based on motion, things like players moving quickly or a ball being passed, and then refines its selection to focus on the most relevant details. This ensures that the model doesn't waste resources on unimportant static parts of the video, like when the game is paused or players are just walking around. To make TimeSoccer even more effective, the authors incorporate complementary training paradigms. These are different ways of training the model to better handle long temporal sequences, such as using techniques that emphasize temporal relationships between frames. For example, the model learns to connect a build-up of play in the first half to a goal in the second half, making the commentary more coherent and narrative-driven. The paper also highlights how TimeSoccer improves upon previous methods. In Figure 1, which compares TimeSoccer to an earlier dataset called SoccerNet Caption, traditional approaches show errors in both timestamp accuracy and the quality of descriptions. TimeSoccer, on the other hand, produces commentary that's closely aligned with the actual events, with green text indicating correct predictions and red for incorrect ones. This visual comparison underscores the model's ability to generate high-quality, context-aware descriptions. In terms of technical details, TimeSoccer is built on the foundations of MLLMs, which have advanced rapidly in recent years for tasks like video understanding. These models integrate visual data from videos with language models to create human-like outputs. For soccer commentary, this means generating text that's not only factual, such as, player A passes the ball to player B, but also engaging and emotionally resonant, like capturing the excitement of a near goal or the tension of a defensive play. The authors conducted extensive experiments to evaluate TimeSoccer's performance. They tested it on full-match soccer videos and found that it achieves state-of-the-art results in SDVC tasks. This means it outperforms other models in terms of temporal alignment, getting the timestamps right, and semantic relevance, making the commentary meaningful and accurate. For instance, the model can describe a sequence like, in the 25th minute, the striker dribbles past two defenders and takes a shot, but it's saved by the goalkeeper, all while ensuring this description is precisely timed to the video. The paper places this work within the broader context of computing methodologies, specifically in computer vision, and keywords like video captioning, multimodal models, and temporal localization. It's published under ACM guidelines, with the authors including Ling Yu, Wenxuan Huang, and others, with Xiaohui Lin, Yang Li, and Changbo Wang as corresponding authors. Overall, TimeSoccer represents a significant step forward in applying AI to sports analytics, particularly for generating automated commentary that feels natural and insightful. By handling long-form videos end-to-end, it paves the way for real-time applications, such as live broadcasts or personalized highlights for fans. This innovation could extend beyond soccer to other sports or even general video summarization tasks, demonstrating the versatility of MLLMs in understanding complex, dynamic scenes.